Moles and Avogadro's constant. In this video, we'll see the relation between moles and Avogadro's constant. And what is the Avogadro's constant? Let's say we have 1 mole of carbon-12. In this 1 mole of carbon-12, we have a mass of 12 grams. If you remember, we said that atoms are very small, meaning these 12 grams contain a huge number of carbon atoms. Nearly about 6 times 10 to the power 23 carbon atoms. Times 10 to the power 23 means we have 23 zeros. Imagine how big the number is. In 1 mole of carbon, we have 6 times 10 to the power 23 carbon atoms. This number is called the Avogadro's constant, which never changes. It's always constant with any element. Let's go back to the book, page 182. 1 mole of anything else contains the same number of particles. So 1 mole of any element we have contains 6 times 10 to the power 23 carbon atoms, which is the Avogadro's constant. For example, 1 mole of magnesium contains 6 times 10 to the power 23 magnesium atoms. 1 mole of water contains 6 times 10 to the power 3 water molecules. 1 mole of sodium chloride contains 6 times 10 to the power 23 formula units. 1 mole of oxide ions contains 6 times 10 to the power 23 oxide ions. And 1 mole of electrons contains 6 times 10 to the power 23 electrons. So when we take 1 mole of any element we have, this mole contains 6 times 10 to the power 23, which is the Avogadro's constant. It doesn't change even with different elements or different compounds.